Good morning, friends. So today we're going to start the module second with the signal flow graph. So x1 is a node, x2 is a node, and x3 is a node. So node represents a variable. So x2, if you can see the equation x2, it is receiving a signal from x1 with a gain t12, and it is also receiving a signal from x3 with a gain t32. So directions are given by the arrow. In this we have three nodes, x1, x2 and x3. Next we have a branch. Branch is nothing but a line joining two nodes, is represented as a branch giving with a direction, and sometimes on the top of the arrow the gain is written. Okay, next is input node, a node which has only outgoing branches. So it is input node or origin node or source node, so which has only outgoing branches is called as input node. If you can see the first diagram here, which has only one outgoing node, okay, so it is called as source node or input node having only outgoing branches. Next is sink node or output node. The node having only incoming branches is known as sink node or output node. In this example below, here we have x4 has an output node or a sink node, which is having only incoming branches, no outgoing branches. Next is mixed node. A node having both incoming and outgoing branches is called as a mixed node. It is also sometimes called as a chain node. So which has incoming and outgoing branches. So here in this example we have x3 here, which has one outgoing and one incoming. So this is a mixed node. Okay. Next is transmittance. It is a gain between the two nodes. It is generally written on the branch near the arrow. So whatever the gain between the two nodes is written on the top of this arrow. For example, here between x1 and x2, the arrow is shown here, and the gain is t12. Here it is t23, t34, and here it is t43, which is a feedback. Okay, next is path. It is connected. Path is nothing but there is a traversal of the connected branches in the direction of the branch arrows, such that no node is traversed more than once. So if you can see, no node is traversed more than once. Or if you can see one forward path, a path which originates from input node and terminates at the output node, along which no node is traversed more than once. So if you can look this RS with a red line, it is starting here, it is starting from here, G1, G2, G3, and ending at the output node. This is one path. It is called as forward path because it is starting from the input node and ending at the output node. And there is one more forward path here, starting from here, RS, G5, G6, G7, G8. So this is one more forward path. In this forward path, no nodes are traversed more than once. Next is forward path gain. It is a product of branch transmittance of the forward path. So we'll see in the next slide what is a forward path gain. Here we have loop, the path that originates and terminates at the same node, and along which no other nodes are traversed more than once. So it starts at one node and ends at the same node, okay, where no nodes are traversed or travelled more than once. So here we have L1. It starts from this point, goes to G2 at this node and comes back here as H2. This is loop L1, so it is given by the gain G2 into H2. So loop 1 is G2 into so we have this first loop which starts from this node, traverses here and comes back to the same node. That is loop 1. Loop 2, this is also called as self loop, which originates and terminates at the same node without traversing any other node. So it starts and ends here only. So here you can see it starts here and it ends here. So loop 2 is nothing but with a gain H3. So the third loop here is, it is starting from this point, coming here and going back again. So it is L3, that is the third loop with a gain G7 into H7. So these are the three loops. A self loop is a path originates and terminates at the same node. Okay, loop gain is nothing but it is a product of branch transmittance of the loop. Loop gain is nothing but what you have here, G2 and H2, H3, G7 into H7. Okay, so that is so next we have non-touching loops, the loops that don't have any common node or a branch. So don't have a common node. So here we have the first loop where we have these two nodes, the second loop here is a node, the third loop is here. So none of these three loops have a common node. That is why they are called as non-touching loops. With respect to this example, we have L1, L2, L3. These all three are non-touching loops because no node are common. So I'll just brief little bit more on non-touching loops. 2 non-touching loops, 3 non-touching loops, and non-touching loops to the forward path. So this will be helpful for the Mason's gain formula while solving the problems. So non-touching loops, here we have seen the example here. Here in this example, you can see, can you make out how many loops are there here? We have this starting from x1, coming at x2 and back again x3. So arrow marks are shown. This is one loop. This is coming here and going back here again. This is second loop. So there are non-touching loops, 2 non-touching loops. If you have to consider, if you have to find out how many loops are there in this figure, can you just tell me how many loops are there? One loop is L1 starting from x1, x2 and ending at x1. Second loop is starting at x0, x4 and back to x0. That is second loop. The third loop is starting at x0, starting at x0, going x1, see the arrow, and coming back again to here. So this is the third loop what we have, starting from x0, x1, x2, x4 and back to x0. So there are 3 loops. There are 3 loops, but there are 2 non-touching loops because the third loop will touch both the loops. So that is the difference I want to tell you. We'll see the second figure here. We have one loop, we have second loop here, we have third. So these are the 3 non-touching loops. Okay, Now here one more example, non-touching loop to the forward path shown. Now can you tell me how many forward paths are there? Forward path is a path which starts at the input node and ends at the output node. So we have, it is like going from one point to the destination. You can have, for example, you want to go to you are traveling to a place and you have 2 to 3 ways to go to that. So that itself is a forward path. So here we can see from the starting node we have this arrow which is going. This is one forward path. This one is one forward arrow which is going. This is the second forward path. Okay, there are two forward paths. So if you consider the second forward path, can you tell me how many loops are there? So we can see there is only one loop which is starting from here and ending here. So this is one loop, and if you consider the forward path from x1, x4 and x5, so this loop here is not touching to this forward path. So there is one loop which is not touching to the forward path. We'll go to the other diagram. First we'll see how many forward paths we have. We have one forward path here, we have another forward path here. Okay, so we have a self loop here. A self loop is a loop which starts at the same node and ends at the same, starts at a node and ends at the same node. So if you see, the second forward path is moving from here and it is nowhere touching the x3 node, which is the self loop. So self loop non-touching to the forward path. If you consider the first forward path, it is obviously touching the node, but when you consider the second forward path, it is not touching this loop. So this is required when we go to Mason's gain formula. That time we have to consider how many single loops or 2 loops or 3 loops which are not touching to the forward path. So we'll see that when we go to the Mason's gain formula. A loop gain, this is the product of all the gains of the branches. So here I have just given an example. We have already studied what is a loop gain. So this is one loop. The gain is G2 into minus H1 is nothing but minus G2 into H1. There are two loops here, one self loop and one more loop is here. The self loop gain is minus 5. The another loop gain is 4 into minus 2. 4 into minus 2, which is nothing but minus 8. So that is the loop gain. So next we'll see methods of obtaining signal flow graph from, there are two methods actually. First method is where the system equations are given and using these equations you need to draw the signal flow graph. The second method is block diagram will be given. From the block diagram you have to construct the signal flow graph. Okay, so those two methods we got to study. So first is from the system equation. So now we'll consider these equations, where first equation is V1 equal to 2 into V0 plus 3 into V2. So here we see the first equation where V1, second equation we have V2 equal to 4V1 plus 5V3 plus 2V2, so on, equation 3 and 4. So first we'll just look into the first equation. So here the V1 here in this equation, if you look all the equations where we can sort out like this can be just you can place it as VI. It is V0 actually, and here it is V0 or V out. Should not be confusing, so I'll just make it VI here, input node. So if you look, we have V1 node. So if I have to draw this signal for this equation number 1, I'll just write a node here with V1. At V1 I am receiving two signals, one from VI and one from V2. VI is an input node, so I'll just draw here one point with name VI. VI, we are getting a signal to V1. Write an arrow showing the signal direction with the gain 2. So where you have 2 VI. So here it is starting at VI and coming to V1 with a gain 2. There is one more signal which is coming from V2. So V1 is this, and I'll draw one more node here. So I'll just draw a node here, which is V2. And which is going a signal to V1 at a gain 3. So at V1 we have input from VI with a gain 2, and we have input from V2, that is a feedback, at a gain 3. So that is what we have drawn here. That is shows here V1 is receiving from input VI with a gain 2, and it is also receiving from V2 with a gain 3. Second equation, we'll see V2, it is receiving from V1, it is receiving from V3 and also from V2. So for V1, so if you see, if you can draw on the same diagram, it is here V2, it is receiving from V1 with a gain 4. I'll draw V3 node here. So if it is coming from the next node, it has to be a feedback. Okay, so that is why I am giving a signal arrow back, that is a feedback. It cannot be a straight line from here in this direction, so that is I am taking a feedback because it is from the next node. So 5V3, and next is 2V2. 2V2 means at the same point I have to draw the self loop with gain 2. So that is what is shown here. So if I include all these equations, I'll end up with this diagram. You can see the third equation V3, which is getting from V2 with a gain 5. So V3 is getting with V2 with gain 5 plus V0. V0 is output node, which is coming with a gain 1 here. So it is 1 into V0, it is gain is 1 here. And V0, the fourth equation, is getting from V3 with a gain 6. So using these equations, I have drawn the signal flow graph for the following equations. So this is the one method is to draw the signal flow graph. You can just go through this. Into a signal flow graph. So I'll be giving one problem as the equations. You need to convert it to signal flow graph, and one more problem I'll be giving a block diagram that you have to convert it into a signal flow graph. So that two problems will be I'll drop it in the WhatsApp group, so you can take it as a assignment, and next class you can just be ready with it. If you have any doubt, you can get back to me. So we'll go with the next. About this Mason gain formula, you'll be this is just a formula and explanation of that. Next class I'll solve one problem using Mason's gain formula, so you'll come to know how delta is calculated and delta K is calculated. As if now, just remember that delta starts with a formula 1 minus single loop gains plus 2 non-touchable loop gains minus 3 non-touchable loop gains. So that is how it starts. Okay. Thank you. If you have any doubts, you can get back to me on WhatsApp or email. Thank you.